So, in the context of the last class, the network architecture, what we studied, we have a layered architecture where the process to process communication and the host to host layers that lie on the or that rest on the network hardware or the network architecture in as a whole. We have the first thing, the basic or the groundwork that has to be done is the network hardware. You have to understand what exactly is the network hardware. Like we discussed in the previous class, if you have a NIC, if you have cables, if you have some fiber optics is given to you and you will be asked to design a network hardware. So, what are the parameters or what are the features that you need to know first, so that you can be a network hardware designer. So, how you classify the different parameters and how you design a network hardware on which you can rest the whole of the protocol architecture or the different communication protocols. So, that is what is your network hardware. Till now what we studied are all the social aspects, the uses, the applications, the types of all these networks. But when you exactly come to the technical issues, we come to the part of your network hardware. This network hardware is usually classified or it is measured in two dimensions. One is the transmission technology and the other one is the scale, or you can say the size. So, when we talk about the transmission technology, we say about the mode of communication, how it is being done, and about the scale we have already discussed yesterday. The scale is depending on the size of the network, it could be your LAN or it could be your MAN or it could be your WAN. So, the scale already we have discussed. Now, coming to the transmission technology part, we say that this can be again classified into two parts or broadly in two sections, two varieties you can say. One is the point to point communication and another is the broadcast. You must be knowing all both of these kinds, but when you go for more details of this technical specifications, what is the point to point and what is a broadcast environment or how the communication actually takes place. In a point to point communication, you have two kinds of again two modes of transmission are there. One is a dedicated transmission and another is a shared transmission. So, we say one is dedicated and another is a shared one. You know what is the meaning of a dedicated? A path is established or a connection is established so that the path will be used only for the particular or concerned communication. We say that is dedicated for that communication. When you talk about this dedicated communication, in that established connection again you have different types of transmission or you can say different ways of transmission. The first method or the first kind of this dedicated transmission is a simplex transmission. The simplex transmission means let us say A and B are two nodes and they establish a dedicated path between them. But in the simplex connection, it is always understood if the A will be a sender and B will be a receiver, that will remain forever. That means the communication is always one directional. Throughout the connection only A can send the data and B can receive the data. B have no choice of transmitting any data to A. That is a simplex kind of transmission. The path is dedicated, but the direction transmission is always one way. Coming to the next variety is a half duplex communication, half duplex mode of communication. In this what happens, let us say same A and B are connected with a dedicated path. In this mode, either A can be a transmitter and B can be a receiver, or B can be a transmitter and A can be a receiver, but the feature is one at a time. When A is the transmitter, B has to be the receiver, and when B has to be the transmitter, A has to be the receiver. That means the transmission is possible in both the direction, but one at a time. That is what is your half duplex mode of transmission. Coming to the another kind of transmission, that is a more popular and more efficient way of transmission called the full duplex transmission. In the full duplex transmission, when A and B are connected through a dedicated path, at any point of time either A or B can be a transmitter or it can be a receiver. Let us say A wants to send the data at some time, that means B needs to be receiver, but also B wants to send the data. So, what it does, B also can send the data to A. That means some kind of synchronization is made between A and B, so that both of them can be transmitter as well as receiver at any point of time. That is what is your dedicated path and 3 different types of transmission between 2 nodes, correct. That is what is your dedicated point to point transmission. Coming to the another kind of transmission, dedicated transmission, which is the shared transmission, meaning you have point to point link between A and B, that path is dedicated, but at the same time A is also connected to several other nodes B1, B2 up to Bn, and B1 is also connected to several other nodes A1, A2 up to An. So, we say the other kind or the other name of this kind of communication, the shared and point to point communication, is multiplexing. We will see this in details when the dedicated path is there, and again when the nodes are sharing their information in communication, how they do it. The paths are dedicated, but the node is shared among the other nodes in transmission. So, we say that is a multiplexing kind of transmission. So, it is point to point as well as shared. Coming to the next kind of transmission, what we studied is the broadcast one. This broadcast has also different type of transmission modes. The same, a dedicated one and a shared one, right. In the dedicated communication of broadcasting, here is a class where I am delivering a lecture to all the students. It is a broadcast medium. Sender is one, but the receivers are many. So, it is broadcasting, right. Coming to the other one, shared one. Let us say we have a medium like this. It is a dedicated path coming to the broadcast. I say A, and there are several other nodes connected to this medium starting from B1 to Bn. A is transmitting and all the nodes are receiving. All the nodes are receiving. So, it is a dedicated broadcast. When you go for the shared and broadcast method, at that time multiple people will be the senders. If A is a sender and B is a sender, another sender, let us say C is another node who is also connected. Sometimes A wants to broadcast, sometimes B wants to broadcast, and sometimes C also wants to broadcast, but the channel is same or the medium is same, right. So, who is given the channel at what time to transmit is a major issue in the shared broadcast communication. If it is dedicated, fine, one channel, one transmitter, multiple receivers. But if it is shared, in that case anytime anyone can be a sender and rest others has to be the receiver, but who gets the channel at what time? This is a major issue. We will study in as a whole chapter on this, the MAC, the medium access and control, how the media is accessed by multiple users, right. Now, in between these two, the point to point and the broadcast, there is another kind of transmission you must be knowing. Can anybody say that? In between point to point and the broadcast transmission, there is one more kind of transmission called the multicast, right. So, the another kind of communication is multicasting. You can say this as a subset of your broadcast. In broadcast, one sender, rest all are the receivers, but in multicast, when it comes to the multicast, this is one sender and a group of people or group of nodes are the receiver, not all. This is multicast, and if you say all this, this is broadcast. You understand the difference between the multicast and the broadcast. So, how this multicasting is done? How a group is identified among all? Those are the issues in the multicasting communication. So, either you have a point to point, one on one, you have a broadcast, one to all, and a multicast, one to many. These are the mode of transmissions. Now, if this is given to you as a hardware designer, you decide how you will have a topology on this. You need to design a hardware topology or a network topology. Let us say you have a one on one, the point to point. What kind of topology you can have? A simple connection between these two, right. If you have a multiple one, you can think for this one, or what we say is a star topology. If you have a bus topology like this, which kind of communication it can support? Shared, it can be a shared one, shared on broadcast or shared on point to point. It can be both. One node can transmit to a single node on the channel or the path, one node can transmit to all in the path, depending on the kind of protocol or the command you use, the network software you use, right. So, your topology says what kind of communication structure or a mode of transmission can be designed or can be achieved if you have a different kind of topologies or connectivity, hardware connectivity among the computers or the nodes, right. Then after this network hardware, let us say everything is given to you, you will be given all the kind of the mode of transmission, the transmission technologies, the size of the network, you will be asked to design a LAN of star topology or let us say dedicated path, or everything is given to you. Now, you designed everything, you did the arrangement of the nodes, you made the connectivity, you had given all the cables, you had given all the ports and the car NIC, everything. So, your network is ready by the hardware aspect. Now, tell me, will the network work now? Can you share the information now? Why not? Because you have not yet designed the protocol or the software that implements, that executes the hardware. So, along with the network hardware, you need to also design a network software. And basically, when we say about network software, meaning it is the set of rules or the set of agreements that are being done, that are being implemented between two entities to communicate with each other, or what we say is a protocol. So, protocol, you can say protocol as an abstract. you can say protocol as an abstract, because no one has seen the protocol what exactly is. And this is an abstract to implement the services. What are the services? The peer services, peer interface services and peer interfaces and the service interfaces. It can implement both. So, when we talk about the protocol, we see the first thing or the major component of your software network software is the protocol hierarchy. The another component of the network software is the design issues associated with the software. When you design any software, let us say any banking software or a library software, what you do first? You first think how I can design a software, right? What are the designing issues? Designing issues means what will be the functionality, how it could be, how it could work efficiently. Efficiently means without any error, how it can get the input data correctly, how it can process it, how it can produce the output. So, these are the different design issues you think when you design any software. So, similar to that, network software also has several design issues. And along with that, what kind of connections it will support, the types of connections. So, first we see about the protocol hierarchies, then we will see about the designing issues and the types of the connections that are supported by the protocols. What is protocol hierarchy? You design a protocol. Protocol means what? A set of commands or set of instructions, and for simplicity what you do? You make different modules, or what you do? You make different layers, because you know that as we saw yesterday there are two things. One is while communicating between two entities or two computers, you first see where the network is, target network is. Then you see where the target host is. Then you see where the target process is. Correct? That means you have different layers of communication. Without identifying a host or without identifying a network, the communication media cannot deliver a data to any process. So, it has to go in a stepwise, in a layered structure. So, you decide, this protocol hierarchy will decide how many numbers of layers will be required for the network software. The first issue is the number of layers. How you decide the number of layers? It is like designing your number of modules in a program. How you decide the number of modules in a program? The modules should not be so large that your interfacing of the modules will be difficult. It should not be so less that the complexity is high. So, you optimize between the number of modules and say that this many number of modules will be enough for solving this problem. The same feature here also, you decide, the designer decides how many layers will be efficient or sufficient enough for a transmission, better communication. So, deciding the number of layers is one factor, and if you decide the number of layers, then you give the name to each layer. You say what are the name of the layers. In a program you have a main module, always you name that as a main, because you understand that this is the root of a program which invokes the others and gets back the result from others. It is intended, it is designed accordingly, so the name is given accordingly. Display is a module, has a specific feature, right. So, different modules, when you name them, their functions are automatically defined. The similar way, when the layers will be designed, the naming of the layer will decide what will be the feature or what will be the function of the layer, correct. So, the layers number of layers are decided, the name of the layers are decided, then you say what will be the content in the layer. It is like you are designing your any program. What will be the content of your layer? Let us say it is a routing layer. Very simple case. Routing means what? It finds a path, it finds a route from a source to destination. That means the content should be designed in such a way that the algorithm should be designed in such a way that it should be able to find a path between two entities or two nodes. The content will be designed accordingly so that it will match the functional or the name of the protocol or the layer. And once the contents are designed or contents are decided, then you say what will be the function, or you can say the services. What we studied is, in the last class, usually there is a layer n protocol where you have multiple layers and the upper layer uses the services of the lower layer, right. So, how these services of the lower layer are defined so that these services can be used by the upper layer. So, that is also defined, and combining all four of these components, starting from the deciding the number of layers, the naming of the layers, the content of the layers and deciding the function of the layers, we say that is a layer n protocol, where n is the number of layers. If the protocol contains 5 layers, we say it is a layer 5 protocol. Every reference model or every protocol has their own layers with different names, different features, different contents and different functions, right. That is what is your protocol hierarchy. Coming to the next one, the design issues. We have certain parameters to be decided. The first one is the error control. Every program you design or every protocol you design must be some errors, must be some error handling features, and you cannot think of any communication without any error, that you know. So, when there is any error present in a communication, how your protocol can handle the error, meaning it should be able to detect the error, it should be able to rectify the error, it should be able to inform the users that there exists an error, or if possible eliminate the error. That is what is handling the error. Some protocols, they have the feature of only detecting. Some protocols, they have the features of detecting and eliminating and also informing to the other users. So, that is what we say is called the error control protocol. There are several error control protocols, we will see in the later sections the details about them. Then there is another design issue called the flow control. What is a flow in communication? The amount of data that is being transmitted, that is what is a flow. So, how the flow is controlled or how the amount of data is being controlled? You have always there is any communication, there are two entities, one is a sender, one is a receiver, and they have different speeds, they may have different speeds. So, if the sender is a faster sender, but the receiver is not, what will happen? The sender can go on sending the data at its own speed without thinking for the capability of the receiver, whether it is able to receive or not. In that case, what will happen? Like you go on pouring water into a bucket which has the capacity of 100 liters, but you go on pouring beyond 100 liters, what will happen? Overflow, the data loss, the water loss, same concept here. So, the sender when sends the data, it must be in synchronization with the capacity of the receiver, and if the receiver has some provision, it has to communicate back to the sender saying, yes, I am ready to receive or you send me the data. In that case, the receiver should be instructed in such a way that it should not make the sender waiting for a long time. In that case, what will happen? The efficiency or utilization of the sender resources are less. That means the sender is underutilized in comparison to its capability. So, both sender and receiver should have a speed control or a flow control protocol depending on which they do the transmission, so that neither the data is lost nor their resources are underutilized. That is what is your flow control. Then another feature is the modes of data transmission, modes of data transfer, that already we have seen, the simplex, the duplex and the half duplex and the full duplex. That is also being considered in the designing issues. And another important feature that is also considered in the designing issues is the addressing. Addressing means, why you need an addressing in communication? To identify an entity. If I give a talk, I must address to specific people. If you are sending a letter to your friend, you must specify his address. If you are calling a friend, you must specify the number you are dialing. That is what is the addressing. So, any sender who sends a data must know the address of the receiver to whom he is transmitting. So, addressing is also a feature which has to be mentioned in every protocol or every packet or every data chunk you send. There is a specific field called the address field. We will see this, all these things in details. So, with all these parameters of error control, flow control, modes of transmission and the addressing, you can better design a network software protocol. So, your protocol hierarchy is decided, I mean the protocol layer n protocol is decided with all its features. Your designing issues are also now ready with you. Now, one thing that is left with you is the types of connection. Types of connection. What do you mean by these types of connection? When a sender and a receiver is connected, how they are connected? How they are connected, or how the service can be given to them. So, these connection types are usually considered of two types. One is connection oriented, another is connection less. You know the difference between these two, the connection oriented and the connection less, and these two are specified with a term called the service. So, connection oriented service, connection less service. You have two features. Connection oriented can be mapped with your telephone. What is that? When you want to talk to somebody, you first establish a connection, you dial the number, then pick up the receiver handset, you talk to him, then you hang up. That means the connection is over, terminated. That is what is your connection oriented. A dedicated path will be established between the sender and the receiver for transmission, and after the transmission it is over, terminated. Connection less services, it can be mapped with your postal service. When you send a drop a letter, you do not know which path it will follow. What is your job? Is to mention the whole address on the envelope and you drop it. It is the job of the postal section to find a route or find a path for the destination, and somehow it goes. If two letters are being destined for the same destination, one may follow this path, another may follow this path, but ultimately they reach into the one destination, single destination, if this is the source. That is the connection less service. Your communication takes place, your transmission is going on, but the path is not established dedicatedly for this communication. Now, how you say which one is better, a connection oriented service or a connection less service? Who decides this? So, every protocol has a parameter called the quality of service. the quality of service will decide whether this connection is better, connection oriented service is better or connection less service is better. You tell me, if reliability is one parameter of quality of service, which one is more reliable, the connection oriented or the connection less service? Connection oriented. The reason behind that? Good. Let us say I say reliability is a parameter to measure the quality of service. You say connection oriented is more reliable, and it is absolutely correct. The reason behind is there is a dedicated path. There is an established path, and that path ensures that the delivery is being done. But when you talk about the connection less, it can be less reliable in comparison to connection oriented. But again, you can add some features like acknowledging, registered post with acknowledgement, all those things. So, to enhance the reliability of the service. So, there are some other features also that we will see. So, quality of service will decide whether the connection oriented protocol is a better one or connection less protocol is a better one in terms of some of the features of quality of service. So, with all these features, you can design a network software, protocols, its contents, naming, then its functions, and what kind of service you are going to give and what kind of designing issues you are going to include in that. So, network hardware, network software, and your interfaces, the peer interface and the next what? The service interface. With everything ready with you now, or the network designer, they designed a reference model for network protocols or network computer networks. We say the reference model. The designers, they introduced two kinds of reference models at the beginning. One is a OSI model, another is a TCP/IP model. OSI stands for Open System Interconnection. TCP/IP, Transfer Control Protocol with an Internet Protocol. The first one is a reference model. OSI is a reference model. It is by ISO usually. And why this is called Open System Interconnection? Because the name was given to indicate any system that is open for communication can use this reference model. That is what is OSI model. And in this model, every layer are distinctly designed. Their services and features are clearly mentioned and clearly defined, but the protocols associated with this are not clearly defined. So, we say this protocol or this reference model is a service oriented model, and for the TCP/IP it is just the reverse. In this protocol, in this reference model, the protocols are clearly designed, but the services are or the designing issues are not clearly mentioned. So, we say this is a protocol oriented reference model. One is service oriented, another is protocol oriented. When you go about this study about the service oriented protocol, you study more of the services of each layer, distinct services, their features, and when you go for the protocol oriented reference model, we study about the features of different protocols and their designing issues. So, we will study these two reference models, OSI and TCP/IP. Coming to the first one, the OSI model, this reference model has got how many layers? 7 layers. The bottom layer is the physical layer, or we say the file layer. Above this layer we have a layer called the data link layer or the DLL. Above this layer we have a layer called the, I am leaving this thing abstract for the time being. There is a layer called the network layer. Let us say this whole is the DLL, actually the whole is a DLL. Network layer. Then above the network layer you have the transport layer. Then you have the session layer. Then you have the presentation layer. Then you have the application layer. Coming to the lowest layer, the physical layer. The role of the physical layer is actually to do the real transmission of the raw data through a media or through a channel. That means, if it is a channel connected to a host or this is a cable you say, the file layer is responsible for pushing the data into the channel in terms of a 0 or a 1. Again, the 0 could be some voltage, the 1 could be some other voltage. Does it transmit the actual zeros and ones? No. It sends only the signals in terms of some voltage, and a particular voltage will signify a 1, another voltage will signify a 0. And that real transmission is the responsibility of the physical layer. So, any data that it gets from the upper layer, when it comes to the file layer, this actually releases the data to the channel in terms of some voltages indicating a 0 or a 1. And the service of the file layer is being used by its upper layer, the data link layer. The responsibility of the data link layer is to check the connections or the data that is being communicated are error free, there is proper flow control maintained, and what it does, it creates some frames. Frame means a chunk of data that will be delivered to the lower layer. So, all these error control issues, the flow control issues are handled by the DLL, the data link layer, and this data link layer is further divided into two sub layers. It has two sub layers, a lower layer and an upper layer. The lower layer is called the MAC layer. This is called the MAC layer. If I say this is a subsection of your DLL, the MAC layer, and the upper layer is called the logical link control layer, the LLC, and both of them are or they belong to the same layer, the DLL. MAC means medium access control layer. This layer says, as we discussed in the shared channel, who will access the channel first, because this is why MAC is given as a lower layer, because this is connected to the file layer, which is connected to your ultimately physical channel or the cable. So, MAC will decide which medium has to be, who will get the medium to transmit the data, and logical link control is the upper layer who will decide all those error control, the flow control issues and all. Then coming to the next layer above the DLL, DLL provides the service to the network layer. The job of the network layer is to route the packets or route the data. Ultimately, delivering of the data means identifying the location of the receiver. And when we are in the area of, or in the era of internet, we always decide where in which network the destination is, and that will be decided by the network layer. How it routes? Like when you enter into a mall, you always get a map indicating which store is located in which floor. So, that is a static one, reference model or reference picture from which you know the route to a particular store. That could be one option. So, either the routing could be with a static routing table, or while you are driving, you suppose you have chosen a route A and you get immediate message that there is a traffic, heavy traffic in that, you decide to go in route B. That is also possible. That means you do a dynamic routing. So, packet has also moved in the same way. Either it can refer to a static table knowing the actual route from the source to destination and it will follow that, or if it has any intelligence, it can use the intelligence to decide another path to reach the destination, and that is what is your dynamic routing. And for both this you have the different algorithms. That is what is the job of your network layer. So, network layer decides the network in which your destination is or the host is located. Now, once your host is located, what is the next job? To identify the process which has to be delivered the data, and that is the job of your transport layer. So, what this does? It does the process to process communication, and you can say this is the actual end to end delivery of data. When you say that network layer delivers the packet into the host, this is not the end of the delivery or end of the communication. Unless the data is delivered to the process, the communication is not over. So, the end to end delivery is the responsibility of the transport layer, who uses the services of the lower layer, the network layer, to do the transmission of the data. And to do all these transmissions, it is the job of the session layer to establish a connectivity or establish a session by means of some dialogue exchange, you know, the handshaking and all, by means of some dialogue exchange, or by assigning some kind of token and all, saying that if this token is active or valid, a session is started for communication. And unless a session is actually activated or started, there cannot be any communication. So, how a session can be started, how it can be terminated, those are the responsibility of the session layer. It uses some mechanisms, some methods by token management or any dialogue exchange or some kind of other handshaking methods, saying that the session is established for the transmission and the session is terminated up to the transmission. Then there is another layer called the presentation layer, who does not look after all these communication technologies, but he sees, this layer says the syntax or the semantics associated with the data to check whether this is a valid data to be transmitted or not. That is what is the job of your presentation layer. And usually these two layers are no more of that popularity. So, some of the reference models, they have ignored these two models, because these jobs are not specific, or any other layer can do those jobs what presentation layer or the session layer are doing in the OSI model. And finally, you have the application layer where the user actually works. You are working in the application layer by using different applications. You have different application protocols like your HTTP, your DNS, www, telnet, anything you say. They are all the application layer protocols. So, when the user sends any data through the application layer, let us say some 1 KB of data is being generated to be transmitted in the application layer. When it comes to the next layer, next means to the transport layer, following the presentation layer and the session layer. In the transport layer, the data is fragmented into small chunks. Let us say 1 KB data is fragmented into 2 chunks of 0.5, 0.5 KB. And those 0.5 and 0.5 KBs I can name as let us say data 1 and data 2. that comes to the, in every layer, this chunk will be added with or encapsulated with some control information of a corresponding layer. So, when it comes to the transport layer divides the data into two chunks D1 and D2 and adds its own header information. We say that is a header information, and that header information contains some kind of control informations. For whom? If I say this is a, let us say this D1 is and D2 are two data chunks generated by the transport layer. Now, the transport layer adds its own header for the peer transport layer. So, whatever header information it adds here will be understood by the peer, not by anybody else. That is the actual protocol or the syntax of the protocol. They do not disturb the data unit, data remains intact. So, they add their own control information here. So, now D1 remains as it is, D2 remains as it is. Now, both of them go to the next layer along with its own header information. It goes to the, from the transport layer, it goes to the network layer. Now, network layer knows which path I have to follow. I have to follow a lane, let us say single road lane or a double road lane. I will decide if two vehicles can pass through, I will definitely prefer that one. If I know it is a single lane road, only one vehicle can pass, I will definitely prefer into that, not prefer into that. That means I know the capacity of the road, width of the road, depending on which I prefer the path. Same here also, the network layer will decide a path depending on its capacity or the present scenario. We will see that later in details, but for the timing, now D1 and D2 they come to the network layer. Now, network layer adds its own control information D1, this was the transport layer information. Now, network layer adds its own data. So, now your data remains as it is, two headers had been added, correct. Now, they go to the next layer. What is the next layer? The DLL. When it goes to the DLL, same D1 along with the two headers that were added, now the next header will be added, that is for the DLL header. This is the network layer header, this is the transport layer header. Same with D1 and same with D2 as well. And one more extra feature of DLL is that it adds another Taylor information. Only this layer has got a feature that adds the Taylor information, and that is the at the DLL. So, now this is a complete chunk of data and called frame. Now, the frame will be transmitted through the file layer into the cable or the channel that you have to be transmitted. Starting from all this header information, then the actual data of both the data chunks D1 and the D2. This happens at the sender side. We will see what happens in the receiver side in the next class.